we're looking at GCR T8. This video deals with worksheet number 4. This is still trigonometry, but we kind of separated out some of the easier from the more complex word problems. So we're going to look at a couple of these. What really makes these more complex, at least the initial group, is that there's basically two trig problems built into one. So this says a flagpole is sitting on top of a building, so you can kind of see our flagpole here. And it's 300 feet from the base of the building. The angle of elevation to the top pole is, top of the pole is 32, and to the bottom is 30. Now some students want to subtract 32 or 30 from 32 and put a 2 in here. You can do that, but that does not form a right triangle, so at this stage we don't want to use that as our technique. We know right triangle trigonometry, so we would work kind of within that parameter. But here's the big idea first, maybe. I'm going to solve for the entire height to the very top of the flagpole to the base, and then I'm going to solve for the height of the building, and I'll subtract these two, and that gives me my flagpole. So let's give it a try now. So I'm going to set up two trig questions, and I'll say, so this is opposite and adjacent. So the tangent of 32, that's the big angle, is opposite y over adjacent 300. So I get y equaling the tangent of 32 times 300. And we'll quickly calculate that, the tangent of 32 times 300. So we find out that the total height is about 187.46. So let's set up the second one. Tangent of 30 degrees is the opposite, x over the adjacent 300. Again, cross multiply. The tangent of 30 this time times 300, and we get the value of x. On my calculator, tangent of 30 times 300, and I get 173.21. Now the answer is the difference of these, so we're going to subtract them. 173.21, sorry about that. 187.46 minus 173.21, and I get 14.25. And it says calculate the flagpole to the nearest foot, so it is, flagpole is 14 feet tall. Quite easy. This one I won't do the whole thing, but we'll set it up, and it's very similar. Actually, you know what, it's identical. But again, the idea is I'm going to track the total height, and then I'm going to track the height of the cliff. So really this sets up the same. Maybe I'll set them up again, but won't solve it. So again, this would be the tangent of 21 degrees is y, the whole length, over the 300 feet away. And then the tangent of 18 degrees is x over 300. And again, I would cross multiply these, find y, find x, and take y and subtract x, and I get the lighthouse. Alright, so there's more like this, but basically they're just two problems built in one. Solve one, solve the other. Sometimes you'll add the values together, sometimes you subtract them, depends on the situation. Let me do one more type of problem. This one's much more complex. It involves a system of equations. Let me give you the initial setup here. You got two ladies that are visiting Paris. This is the Grand Cathedral Notre Dame, and they're looking up from where they're standing to the top of the cathedral. Now what differs here is they're both looking at the same place. We have their angles, we have the total distance between the ladies, but we do not know the exact amounts. And what they want us to find is the height of the spire. So what I'm going to do is start by placing an X on this side, and that leaves whatever's left over of 300 minus X as this distance. If this is X, this is 300 minus X. That's an important step in this problem. So let's back out now and take a look. So 2 girls and 3 parts. So what we're going to do is we're going to name this to be the height of the spire. And from Betty, let's see, yeah, Betty's over here. Let's put B by Betty and Kathy over here. All right, so in Betty's case, she sees the tangent of 22 is opposite h over x. And when we multiply this, we get h equals the tangent of 22 times x. Now in the case of Kathy, she's looking at it at 30 degrees, and the opposite is h, and the adjacent is 310 minus x. Now when we multiply this, we get the tangent of 30 times 310 minus x. What I want you to notice is we have 2 equations with 2 unknowns. We don't know the h's, and we don't know the x. This is a system of equations. But in this case, it's quite simple what to do. We both are equal h. H is the same for both of these groups. So we're going to set these equations equal to each other. So the tangent of 22 times x is equal to the tangent of 30 times 310 minus x. I'm going to keep the math rolling here. Stick with me. I'm not going to turn these to decimals. I know some people like to do that. I'm not in that business. I like to keep them like this. You'll see why here. Things stay fairly clean. Okay, see what's happened? I distributed this in. I'm going to bring over my x's. So again, I'm still moving along. The tangent of 22x plus the tangent of 30x equals the tangent of 30 times 310. At this stage, so that you can stick with me, I'm going to turn these into decimals, and you'll just see it turns into a very easy little equation. So the tangent of 22 is 0.404, and the tangent of 30 is 0.577. And this is just a number. The tangent of 30 times 310 gives me 178.98. Let's combine our x values. 0.404 plus 0.577 gives me 0.981x equals 178.98. And when I divide those, I get, let's see, 178.98 divided by 0.981, I get 182.45. Now this isn't our answer, we're getting much closer. Let's go back to our diagram for a second. What this is x, so we know that this person's 182.45 away, and this person is 310 minus that amount, which is the 127.55. So one of the variables has been solved, and so all we have to do is now just find h. So let's go back to the original one with Kathy. So hers was the tangent of 22 is opposite h over her adjacent, which is 182.45. Almost there, cross multiply, we get the tangent of 22 times 182.45, and we get, sorry, my paper ran out there, tangent of 22 times 182.45, and we get a height of 73.71 feet, and they want it to the nearest feet. 74 feet tall is that spire. Just so you know that this is not actual data, but that's how we do it. So I guess all I would say is you set up the 2 equations. They will always equal, heights will be in both of them, so you can always set them equal. And then really all this is solving an equation. It is different to have the tangents and things in there, but they turn into decimals and things just work out as they should. All right, thanks.